this. It will be posted up on YouTube later today or tomorrow, but it should be up by this evening. And I already have a question asked. So if you do have a question, you can raise your hand, type it into the chat. But I'm going to go ahead and start with question 25, since that was the first question asked. And I'm going to use the blueprint that you guys should have received. So let me just pull that up. So this is the same blueprint you were emailed. So I'm assuming that's the question 25 we're referencing.
Yes.
Okay. All right. So you saw questions like this last semester where you did, you were converting units per hour to milliliters per hour. So that's what this question is asking. Now, what I'm going to do is I'm going to copy this because I'm going to create a alternative question that you'll be able to reference. And we'll change the variables here in just a minute. So just don't start answering that just yet. All right. So let's look at this question. What this question is asking, this is, you were introduced to this in 220, 230. What this question is asking you for is they want you to be able to convert units per hour to milliliters per hour. And this is what you do when you are doing the heparin protocol, right? Because the heparin protocol tells you, you get to an answer that is in units per hour, and then you use the heparin infusion, or you use the heparin IV information to calculate your infusion rate. So we're doing the same thing here. And the reason I write this out is because sometimes it's helpful to see, okay, we have units per hour and we're converting to milliliters per hour. So it gives you a strategy of how to solve these. Now, over the years, I've done this a variety of different ways. As long as you're getting the right answer, you're doing it correct. So I'm going to start off with the units per hour. So it says 750 units per hour. And what I want to do is I want to convert that to milliliters per hour. So in order to do that, I need a way to convert units to milliliters. Just so happens that this patient is hooked up to an IV solution. The IV solution is 25,000 units of heparin, and then it's a 1 liter bag. So I'm going to use that information to calculate and convert units per hour to milliliters per hour. So what's my units? 25,000. Now I don't have milliliters listed, but you guys know that 1 liter is the same thing as 1,000 milliliters. So we'll just put that right there. And then we're just going to multiply across the top, divide by the bottom. So when I do that, 750 times 1,000 divided by 25,000. I'm going to get an answer of 30 milliliters per hour. So let me give you an alternative. Let me change some of these things. So let's say it's, you're welcome. Let's say it's 1375 units per hour. This is going to be an awful question, but it'll work out. Oops. 1375 units per hour. We'll leave it at 25,000 units, but this time it's a 1.5 liter bag of dextrose 5% water. So go ahead and calculate your ml per hour, given the new numbers. And then I will jump to question 29 after we get some answers for 25, the alternative 25. All right, so let me just confirm, because I don't have that answer yet. So I'm going to take 1375 times 1,500 divided by 25,000. And I'm going to get 82.5 milliliters per hour. So if you come back to this, you can at least hopefully get to the same answer I got. All right, let's look at 29. Good, perfect. All right, so you can see I already answered this. So what you need to know is, first of all, we don't know, I don't know what these M's mean. I don't know. But it tells us it's a 1 mil tuberculin syringe. So here's the 1. So that must be what is referencing the mil syringe. So it would just be marking 0.5 on the syringe. And I did a bad job of marking it. So you would want to make sure you're right on that line when you're marking the syringe. All right. Any other questions you want to work through? There were a few questions that were incorrect on the like the key was wrong. So I did reach out to Professor Nanju and we got that corrected. So if you and then I also worked through it during the review on Tuesday. So all right, so I see question 11. So let me I'll get to question 11, but let me bounce since we're really close to 31. We'll do that real quick. All right, so you've seen the heparin question. Now, the biggest thing is to remember to convert the patient's weight in pounds to kilograms, and then just to follow the protocol. Okay, so we did this last time, so I'll just show you this here. We took the patient's weight, multiplied by what it told us to bolus, which is 80, and that's the standard. Anytime you do a weight-based heparin protocol, 80 units per kilogram is the bolus dosage strength, or is the bolus dose order. And then what you have available is 1,000 units per milliliter for the bolus dose. So you just have to remember to convert that to units to milliliters. And then what you get is as a shorthand, because the only thing that really changes on this question is the patient's weight. So if you want to do this as an alternative, like I did down here, just change the patient's weight. So if you're going to use a 198-pound patient, if you're going to use a 245-pound patient, you choose the weight, convert it to kilograms. And then if you want to verify your answers, you can always email me and I can tell you if it's right or not. And I'll just tell you whatever your kilograms are. All I'm going to do is I'm going to take that times 80 divided by 1,000. And then as long as your answer matches up with my answer, then we'll be correct. And then the same thing for the infusion rate. I'm going to take the kilograms times 18 divided by 100, and then I'm going to get the infusion rate. I've had students ask me, where am I getting this 100 from? It's the relationship between 250 ml and 25,000 units. As long as you're following the standard heparin protocol, where it tells you what you have available, this 25,000 units, 250 milliliters, half normal saline, that's where I'm getting that information from. And like I said, that's the standard weight-based heparin protocol. Okay.
So for the short ones, that would work on any like equation if they were different numbers or no?
So, well, if you're saying like if it was different, if it was a different bolus strength, a different starting order, then it wouldn't work. You would have to use this only works for this question that is following the standard weight-based heparin protocol, which is what you will likely see.
So if we're gonna most likely see it, so if there was different, would the thousands be different, like the 100 be different, basically then? But the kg times 80 and the kg times 18 would be the same, right?
And the 1,000 and 100, if it's following the standard weight-based heparin protocol, this thing, like if you do a Google search for standard weight-based heparin protocol, you're going to see everything that's listed here.
Okay.
So that, as long as it's listed that way, then this will apply. But I have seen alternatives to this question where like they use 25,000 units in 500 milliliters half normal saline, but it wasn't the standard weight-based heparin protocol. It was a completely different type of question.
Okay, thank you.
You're welcome. Yeah, I know I'm not answering it directly. Sometimes you're asking a question that I may not be able to answer directly because I don't think that's how they're going to get you on this. They just want to make sure you can do the math and can you like do this heparin protocol. I don't think they're going to change a whole bunch of things on you, but you need to know where to look for it, right? So you need to know that the available is listed here, or alternatively, it might be listed like this, where it tells you, here's the available, here's the order, and they skip the whole all that extra stuff that's listed in there. But since Professor Nanju put that in there, you need to know that this is most likely how you're going to see it on your test. And it should be the same way you saw it last semester. Last semester, you had a heparin protocol question. You will get 2 questions, calculate the bolus, calculate the infusion rate, but it'll count as one question. And I think someone asked that. All right. I'm coming back to 11. 28. Okay. So the trick with these questions is, especially when you have a label that has like a lot of stuff listed on there, you always want to use what they're telling you to utilize. What I mean by that is, so it tells you they're looking for 0.125 milligram IV push. So you're looking for milliliters. You're going to use the label to determine what you're going to use. And so basically you have a bunch of information here. It tells you 500 micrograms, which is the same thing as 0.5 milligrams in 2 milliliters. It also tells you 250 micrograms, which is the same thing as 0.25 milligrams per ml. So basically they're just telling you all the same thing. So what you're going to do is you're going to choose one of these options. I would say, since it's in milligrams, stick with the milligrams so you can kind of ignore micrograms. And then I always like to just not have to deal with an extra number. So I'm just not even going to look at this, and I'm going to use the 0.25 milligrams per milliliter to do my calculation. So my order is 0.125. My available is 0.25 milligrams, and my quantity is 1 mil. My guess is that when you are first seeing that type of question, you're saying, OMG, why is there so much information listed on here? Well, that's because some people are doing it in micrograms when they do the order. Some hospitals or some facilities are using it in micrograms. Some are using it in milligrams. So they want to have those options. I'm not personally a big fan of that because it just seems like it creates more distraction, but that it is what it is. So, and then you would just plug that into your calculator. 0.125 divided by 0.25, and then you're going to get 0.5 ml. Sometimes it's helpful. Like, I know that when I first seen a couple things that I'm like, how do I even navigate this question? And then when you have someone showing it to you, sometimes it just helps to make it like, oh, okay, that's why we're getting rid of all this extra information. It's just that it's redundant. It's just telling me the same thing. It's saying this is micrograms, this is milligrams in 2 milliliters, and then we divide it by 2, and it's 500 divided by 2 is 250. 0.5 milligrams divided by 2 is 0.25 milligrams. And now you know where that's coming from. Okay, let's get to 11. 11 is going to be the question I don't like. I know it. Yep. Okay. The only reason I don't like it is because it just takes forever to go through it. So I remember, Kevin, are you on here? Yeah. So I'm going to, I told Kevin I would do this in a chopped up fashion. So let me just create an alternative question. Let me just copy this. And when I say I don't like this question, I just mean I don't like it because it's long. It takes a while to explain. But otherwise, I have no problem with this question. So I'm going to change the variables on this. I'm going to say 7.5 micrograms per kilogram per minute. We're going to say that this is a, let's just say it's an 80K. And then I'm going to leave the dopamine available as is. And then what I'm going to do is the first time I did this on Tuesday, I just did it as one long dimensional analysis problem. Okay. But I'm going to show you how to chop this up, and you can get to the same answer without doing a long dimensional analysis if that's not your cup of tea, as it were, for how to learn these things. So let me give myself some room. So what this question is asking you is, we want to convert this microgram, kilogram, minute to milliliters per hour. And we're going to have to do a couple of things to get to that answer. So there's a lot of conversion. So you typically are told you have a two-step or a nitroglycerin or nitroglycerin titration question. You're basically getting a multi-step. So this is beyond two steps. But it's a fair question. You should be able to do it. It is a hard question, but after I show you what to do, hopefully it'll make a lot of sense. So the first thing I'm going to do is I'm going to kind of try and get rid of units. And what I mean by that is I have the 7.5 micrograms per kilogram per minute, and I have 80 kilograms. I'm going to combine those two numbers in order to get rid of kilograms. So at least now I'm just left with micrograms per minute. So step one for me is I'm going to take the patient's weight times the order, which is the 7.5 micrograms kilogram per minute. Okay. And then so 80 times 7.5 is going to be 600 micrograms per minute. So we got rid of kilograms. They're done. They're out. We don't need to worry about those anymore. And now we have something, at least we just have 2 units. We don't have 3 units anymore. So my final answer is in hours. Okay, so I know that already. Why not just go ahead and convert minutes to hours? So what I'm going to do is I'm going to multiply by my conversion factor for minutes to hours, which is 60 minutes in an hour. And then what that's going to give me is 600 times 60. I'm going to get 36,000 micrograms per hour. Now, you've known this for a long time. You were introduced to this concept in middle school, if not middle school, high school. And if not either of those, your prereqs for coming in, because I know we talk about it in general biology. But whenever you're doing math that involves the metric system and involves units, the units need to be the same. So right now we have milligrams and we have micrograms. Those two do not, you can't do math easily. I mean, you can. It is possible. If you can think in those terms, you can certainly do it. But easily, you're not going to be able to do it. So what you want to do is you need to be able to convert either milligrams to micrograms or convert micrograms to milligrams. So it's really up to you, whatever you want to do. But since we're here and we're doing this and it's good practice, why don't we convert micrograms to milligrams? And so I'm going to do that by setting up another conversion factor. Micrograms, milligrams. And again, the reason we're doing this is because I need to be in the same units in order to continue the math. So you know that 1 milligram is the same thing as 1,000 micrograms. So that's going to give me 36,000 divided by 1,000, 36 milligrams per hour. The last step is we just need to convert milligrams per hour to milliliters per hour. So this is very similar to what you would do when you're converting units per hour to milliliters per hour. It's just you're just combining your knowns. So 36 milligrams per hour. I don't want milligrams. I want milliliters. Do I have a way to convert milligrams to milliliters? I do. That's where the available comes into play. 400 milligrams, 250 ml. And then what we're going to do is we're just going to run that calculation. We're going to take 36 times 250. And then divide by 400. And then you're going to get an answer of 22.5 mil per hour. You got it. Perfect. So in my opinion, this question is worse than the heparin protocol question because there's so much extra work to do. You have to convert minutes to hours. You have to convert milligram or micrograms to milligrams, and then you have to convert milligrams to milliliters. There's a lot of stuff that you have to do for this question, but hopefully now you can see how that's done. I chunked it out. Hopefully that makes it easier to follow. And if you're doing this with me, like later on the replay, just at the start of this question, just pause it and then just see if you can do it before I do it. Okay. And then what's going to change? Probably the order and then the patient's weight. But other than that, it's going to be the same or similar flow.
Wouldn't it just be easier to convert the MCG to MG before you even start the problem? Like, wouldn't that take away like 2 or 3 of these steps?
Yeah, as long as you get the same answer at the end, that's perfectly fine.
Okay.
I want you to know, like, the way, like, to look at the reverse of that. So when I look at this problem, I don't see 400 milligrams. I see 0.4 micrograms, and I just solve from there. I save that step. So I take 7.5 times 80 divided by 0.4 times 250 times 60 equals, and then I get my answer. But you're exactly right. Like, I definitely did a long-winded approach, but if you have a shorter way and you're getting the same answer, you're doing it right. Good question, by the way. All right, so this is you've seen this since 110, right? So your fluid replacement volume. There's a variety of ways to answer this. The way that I've kind of wrapped my head around it, because I know that this is the type of question that I'm going to see with this particular thing, is I always take I take my actual output, so my actual urine output, I put it over my what is called expected output, and I multiply it by my replacement volume. Now, the reason I do that is because I've just simplified this. So like, some students will just do like, like a ratio proportion, and that works out great too. So I'm just letting you know like what I do. So it says for every 150 milliliters out, you're going to replace with 40. And what was actually voided was 600 milliliters. So what I'm going to do is I'm going to take my actual void, 600, over my expected, or for every, which is 150. And I'm going to multiply by the replacement volume, 40. This problem poses it's a little bit tricky to do it in the purest sense for dimensional analysis. You can do it. It's just that everything's in milliliters, which makes it seem, odd. But you just set it up like that. So you're going to take 600 times 40 divided by 150. And then you're going to get a replacement volume of 160 milliliters. And the only way this could be changed, we could say for every 200 milliliters of urine output, replace with 50 milliliters of water. And for the last 4 hours, it was, 700 milliliters. Whatever it is, you just plug it into that makeshift formula, your actual output over your expected output times your replacement volume, and then you should be good to go. You're welcome.